Welcome to the deep dive. Today, we're going to be diving into supervised learning.
Oh, yeah,
One of the most important parts of machine learning.
absolutely.
And we're going to be focusing on all the stuff that you sent over,
Awesome.
your notes, research, and articles.
Looking forward to it.
Yeah, so we're going to be covering some of the fundamental concepts of supervised learning.
Okay.
We'll talk about the types of algorithms
Yeah.
and how it's being used in the real world.
Okay.
So to kick things off,
Yeah.
what is supervised learning really?
A lot of people hear that term, but they don't really get what it means.
Yeah.
You can think of it kind of like training a dog.
Okay.
Give a dog a treat when it does something good.
I see. So the dog is like the algorithm,
Exactly.
and the treat is like the feedback.
Yes.
The trick is the output.
Exactly.
Okay.
So in supervised learning, we're basically teaching an algorithm,
Okay.
and we do that by giving it labeled data.
Labeled data.
Yeah. So this is data where you have like an input,
Mm-hmm.
and then it's paired with the correct output.
Got it.
And the algorithm learns from these examples.
That's where the supervised part comes in.
Yeah, we're supervising it.
Giving it feedback.
Exactly.
See what I mean?
Just like with a dog. The quality of the data is super important.
Oh, yeah. Garbage in, garbage out. Right.
Exactly.
So I remember in the notes, you were talking about splitting the data
Yeah.
into training and testing sets.
Yes. Very important.
Can you explain that?
Of course. So it's like when you study for a test,
Okay.
you don't want to just memorize the answers, right?
Yeah, that's just cramming.
Yeah, you want to actually learn the concept so you can answer new questions.
Right.
So we do the same thing with supervised learning.
Got it.
We take that labeled data and we split it into two parts,
Okay.
a training set and a testing set.
Okay.
And the algorithm learns from the training set.
And the testing set is like the real exam.
Exactly.
Okay.
So that way we know it can apply its knowledge to new data that it hasn't seen before.
Yeah. So like a quality control check.
Exactly.
Now, how do we know if the algorithm is actually doing a good job?
Well, that's where the loss function comes in.
The loss function.
It basically tells us how far off the algorithm's predictions are from the actual values.
So if the loss is low, that's good.
Exactly. The lower, the better.
So we want to minimize that loss.
Yes. And during training, we use what are called optimization algorithms
Okay.
to help the model minimize that loss.
Like fine tuning.
Exactly.
What's an example of an optimization algorithm?
Well, one that's really popular is called gradient descent.
Okay.
So imagine you're trying to find the lowest point in a valley.
Okay.
Gradient descent helps the algorithm take little steps down towards that lowest point.
I see.
So it's gradually moving toward minimizing that loss.
Okay. So as it's training, it's getting better and better.
Exactly.
Okay. So we've talked about data and loss functions.
Yeah.
Now I want to get into the different algorithms.
Okay, yeah.
Because that's really where the magic happens, right?
The heart of it all.
So where should we start?
Let's start with classification algorithms.
Okay.
These are the ones that help us categorize things,
Sounds good.
put things into buckets.
Okay.
So one of the simplest ones is called logistic regression.
Oh, yeah. I remember reading about that.
Yeah. Have you used it before?
Oh, I haven't used it, but I remember it has to do with probabilities, right?
Exactly.
Like how likely something is to belong to a certain group.
Yeah. So it's often used for yes or no questions.
Okay, so will this customer click on this ad?
Exactly. Or is this email spam?
Okay, so it figures out the probability, and if it's high enough, boom, spam folder.
Yeah.
That makes sense.
Simple but effective.
What about support vector machines?
SVMs, those are cool.
Sounded really complex in your notes.
Yeah. So imagine you have a bunch of data points.
Okay.
And you're trying to draw a line to separate them.
Okay.
That's basically what an SVM does.
Okay, so it finds the line.
Yeah, the optimal boundary.
But it doesn't have to be a straight line.
Right. It can be more complex.
Especially if you have a lot of variables.
Exactly. And that's where something called the kernel trick comes in.
Okay.
It lets SVMs make nonlinear boundaries,
Okay.
even in high-dimensional spaces.
Wow.
Pretty powerful.
So they can handle a lot of different problems.
Yeah, like image classification or text categorization.
Okay, cool. What's next?
How about decision trees?
Oh, yeah. Those are the ones that are choose your own adventure, right?
Yeah, it's a great way to think about it.
Okay.
So basically, it's like a series of decisions
Okay.
based on the features of the data.
So if this, then that.
Exactly.
Yeah.
So each decision splits the data up
Okay.
until you get to a final classification.
So it's like a game of 20 questions,
Yeah.
and it's easy to understand how it works.
Right. You can actually see the logic.
Okay, that's good, especially if you need to explain it to somebody.
Right.
Now, what about random forests?
Nice. So those are kind of like ensembles of decision trees.
Ensembles, like a bunch of them together,
Yeah.
like a musical ensemble.
Yeah. So imagine you have a whole forest of these trees.
Okay.
Each one is trained on like a slightly different subset of the data.
Okay.
And then you combine their predictions.
So like a second opinion.
Yeah. But from a whole bunch of experts.
Wow.
And they're known for being very accurate,
Okay.
especially for complex data sets.
Oh.
And then there's naive Bayes.
Now that one's good with text, right?
Yeah. Remember?
I think so.
So it's based on Bayes' theorem,
Okay.
which is all about probabilities,
Okay.
updating our beliefs as we get new evidence.
Okay, so it looks at like the words in an email
Yeah,
to decide if it's spam.
exactly.
Okay.
Called naive
Yeah.
because it kind of assumes that the words are independent of each other.
Okay.
But it works really well for things like spam filtering
Interesting.
and sentiment analysis,
Okay.
like figuring out if a review is positive or negative. And then there's K-nearest neighbors, or KNN.
Oh, yeah. This one's all about like finding similar examples, right?
Exactly.
It's like judging a data point by its friends.
Yeah, so basically,
Okay.
it looks at the K closest data points.
It looks neighbors.
Yes, it's neighbors.
Okay.
And then it assigns it to the same category as most of its neighbors.
So if most of your friends like a movie, you'll probably like it too.
Exactly.
Okay, so we've covered a lot of classification algorithms.
Yeah.
Now we can't forget about neural networks.
Ah, yes, the rock stars.
Yeah, those are the ones that are like modeled after the human brain, right?
Exactly.
Okay, so it's like a mini brain in the computer,
Well, kinda.
making decisions.
Yeah, they can learn really complex patterns.
Okay,
So they're good for things like image recognition and natural language processing,
that's wild.
and even like playing games.
They can play games.
Yeah, like Go.
Wow. So before we move on, can you remind me what's the difference between classification
Sure.
and regression?
So in classification, we're predicting a category,
Okay,
like spam or not spam.
got it.
And in regression, we're predicting a number.
Yeah.
Like
Yeah,
the
okay.
price of a house.
Okay, so like how much will this house sell for?
Exactly.
Okay, so classification is about categories and regression is about numbers.
Yeah.
Okay, cool. So let's talk about those regression algorithms.
Yeah, let's do it. Okay, so we're going to jump into regression algorithms.
Yeah, those are the ones that predict numbers,
Exactly.
like the price of a house or the temperature tomorrow.
Yep, and there are a bunch of different algorithms for that too.
Okay, cool. Let's hear about them.
Okay, so one of the most basic ones is called linear regression.
Linear regression. Okay.
Yeah, so you know how we were talking about drawing a line to separate data points?
Yeah, with SVMs.
Well, it's kind of like that.
Okay.
But instead of separating the data,
Yeah.
we're trying to find the line that best fits the data.
Okay, so it's like drawing a line through the middle of a point
That-
to see the trend.
Yeah, so we could use that line to make predictions.
Okay, so if the line is going up, we know the values are going up.
Exactly.
And if it's going down, they're going down.
Exactly.
What if the data isn't really in a straight line, though?
Well, that's where polynomial regression comes in.
Polynomial. Okay.
Yeah, so instead of a straight line,
Yeah.
it can fit a curve to the data.
So like a parabola.
Exactly.
Okay, that makes sense.
So it can handle more complex relationships.
Cool. So we've got lines and curves.
Now, what about something like support vector regression?
SVR.
Yeah, you got it.
Okay.
So remember how we were talking about SVMs finding the best boundary?
Yeah.
Well, SVR does something similar.
Okay.
But instead of separating categories,
Yeah.
it's trying to find the line that best fits the data while staying within a certain margin of error.
Okay, so like a buffer zone around the line.
Yeah, exactly.
Cool. And what about decision trees?
Yeah, we can use those for regression too.
Oh, really? I thought those were just for classification.
Yeah, but instead of predicting a category at the end of each branch,
Mm-hmm.
it predicts a numerical value.
Okay, so like instead of saying this is a cat,
Yeah.
it says this cat weighs 10 pounds.
Exactly.
Okay.
And just like with classification, we can use random forests for regression as well.
So a whole forest of decision trees predicting numbers.
Yep, working together to give us a really good prediction.
That's amazing.
And of course, we can't forget about neural networks.
Ah, yes, the neural networks.
Yeah, they're really good at regression too.
So they can predict categories and numbers.
Exactly, they're very versatile.
Okay, so we've talked about all these different algorithms.
Yeah.
Now, how did these actually get used in the real world?
Oh man, in so many ways.
Yeah, I know we touched on a few examples.
But it's really everywhere.
So what are some of the coolest applications?
Well, one that you probably use all the time is personalized recommendations.
Oh, yeah, like Netflix and Spotify.
Exactly.
How do they know what I want to watch?
Well, they use these algorithms to analyze your viewing history, your ratings,
Mm-hmm.
even how you interact with the app.
Wow.
to figure out what you might like.
It's kind of creepy how well they know me.
I know, right?
Oh.
So what else?
And, well, healthcare is a big one.
Healthcare. Okay.
Yeah. So, like, imagine algorithms that can look at medical images,
Okay.
like X-rays and CT scans,
Oh.
and detect tumors or other abnormalities.
That's incredible.
Yeah, it could really help doctors.
Yeah, make faster diagnoses.
Exactly.
It's amazing.
And it's not just images.
Yeah.
They can also predict patient outcomes,
Wow.
help personalize treatments,
Okay.
even identify potential new drugs.
So supervised learning is like saving lives.
In a way, yeah.
What else?
Well, how about financial fraud detection?
Oh, yeah.
So every time you buy something online,
Yeah.
there are algorithms running
Okay.
to make sure it's not fraudulent.
So that's how they catch those stolen credit cards.
Exactly.
That's good to know.
And then there's natural language processing.
Things like chatbots
Yeah, I
A
love chatbot.
and language translation
Hmm.
and sentiment analysis.
Sentiment analysis with that.
So it's like
Okay.
figuring out the emotional tone of text.
Oh, so
Yeah.
like if a customer review is positive or negative.
Yeah.
Interesting.
So companies can use that to understand how people feel about their products.
That makes sense.
And, of course, we have self-driving cars.
Oh, yeah, the self-driving cars.
Those are like the ultimate example.
Yeah.
They use supervised learning to see their surroundings,
Okay.
make decisions, and drive safely.
That's crazy.
I know, it's mind-blowing.
Yeah. So it seems like supervised learning is being used for everything.
Yeah, pretty much.
It's amazing.
And it's only going to get bigger.
I know. What's next?
Well, we've covered a lot,
Yeah.
but it's important to remember that supervised learning has its limitations.
Okay, so it's not perfect.
No technology is perfect.
So what are some of the downsides?
Yeah, so one of the biggest limitations is that supervised learning really needs a lot of labeled data,
Oh, yeah, that makes sense.
like a ton of data.
And that data has to be labeled correctly.
Exactly. And that can be a problem in some areas.
Yeah, like where it's hard to get the data or it's expensive to label it.
Right, exactly.
So what else?
Well, another problem is that supervised learning models can sometimes overfit the data.
Overfitting.
Yeah, so it's like they learn the training data too well,
Okay.
and then they don't generalize well to new data.
So it's like that cramming for the test thing again,
Yeah, exactly.
where you memorize the answers, but you don't actually understand the material.
Right, so they can get really good at answering questions about the training data,
Okay,
but then they struggle with real-world data.
that makes sense.
And then another limitation is that supervised learning isn't very good at handling situations where the data changes over time.
Oh, okay, like a dynamic environment.
Yeah, exactly.
Okay, so it's not so good with moving targets.
Right.
So it seems like supervised learning is really powerful,
Yeah, it is.
but it's important to be aware of its limitations.
Absolutely.
Okay, well, this has been a fascinating deep dive.
Yeah, it has.
I've learned so much about supervised learning,
Me too. It's always fun to talk about this stuff.
and I think our listeners have too.
I hope so.
So thank you for joining us,
It's been a pleasure.
and keep on learning.
Yeah, stay curious.
We'll see you next time.
See ya.